Welcome back. Now, we're going to talk about how you can expand this simulation to include additional elements not present in the initial simulation. So, to begin, let's go to the settings page here, and the first thing we're going to want to do is enable microphone input. This will let us talk to the system and get responses. Next, we're going to turn on our virtual assistant system. To do this, we're going to have Dr. Arnold here take the place of that virtual assistant and speak for the system. So we're going to set that here, and we're going to make the virtual voice set to Justin so it matches the times we have him speaking. So with this, we have added, or I should say we've set up the initial settings here for that to work for that. Okay, next we're going to go to the AI tab. Now, the AI tab lets you add in additional components and enable the functionality to where you're able to speak with an agent and get responses. This agent is aware of everything that is inside of your simulation, as well as what you give it as a prompt to begin. To enable this, you have to click the Enable AI Chat button. Here you can see the different language models that you can enable, as well as the sim knowledge base if you want it to have the ability to adjust or control things in your simulation, such as you can ask it where is the chemistry spatula, where is the Bunsen burner, and things like that, and it will be able to then take actions and highlight them within the simulation. If you want that enabled, you can click this. Enabling PDF question and answering will make it so that if you add in a PDF, it will be able to read and know what's in that PDF. And chunking responses has to do with how the agent responds and how quickly, and whether or not it is in one block of text or if it will take the time to wait until it has received all of the responses and then send it as one solid chunk. By default, this will be enabled. Now I'm just going to have this name match that of this one here, so he knows. And we're going to give here a prompt to the agent so that it knows about what its goal is and what it's here. Basically, we're going to say it's a helpful science teacher who is conducting the Tollens flame test with students. Answer their questions about the chemical compounds and the results of their experiment. And the three samples they have been provided HCl as a cleaning solution. All right. So with this, we have set up our chit chat. If we want to, we can test this with the conversation system here. So currently, as we have not enabled this, there are no past conversations. Here's where you'd be able to view them. You can also test your agent here by starting a new conversation, and it's going to refer to what we gave it as its prompt. So for example, I can go, "Hi there. What is the Tollens flame test?" It's going to think for it a little bit, give a response. Okay, copper produces green, potassium violet, strontium gives off red. Okay, and I can ask what does HCl stand for, and it should be able to tell me it's hydrochloric acid. Excellent. And what are some of the... you know what? I'm okay with this test here for now. So with this, I'm going to actually save this and now experience my simulation as what we had before. Okay. So we have the same thing before, but now I can talk to Dr. Arnold here. So, hi Dr. Arnold, what can you tell me about the Tollens flames test?
Hello there. You might be slightly confused, as the Tollens test and flame tests are two different chemical tests. The Tollens test is used to determine whether a substance is an aldehyde or ketone. It involves the use of Tollens reagent and results in the formation of a silver mirror, if an aldehyde is present. On the other hand, the flame test is a procedure used in chemistry to detect the presence of certain elements, primarily metal ions, based on each element's characteristic emission spectrum. The color of the flame corresponds to the metal in the compound and can help identify the presence of specific metals in a sample. Today, we're focusing on the flame test. We'll be testing for the presence of potassium, strontium, and copper. Each of these will produce a unique color that will help us identify them.
As you can see, it's able to answer questions that you have about your simulation, and we're still able to go through it as we would normally. So I can still do this process. Can you tell me what is potential dangers I might face working with a Bunsen burner and things to watch out for?
Absolutely, safety should always come first. Bunsen burners can pose several risks if not used properly. Here are some potential dangers. 1. Burns. Bunsen burners produce a hot flame, which could cause burns if you accidentally touch it or if flammable material comes into contact with it. 2. Fire. The flame could set flammable materials nearby on fire if they're too close. Always ensure that there's nothing flammable near the burner. 3. Gas leaks. If the gas valve is not turned off properly, it may lead to gas leaks which can be dangerous. 4. Glass breakage. Heat from a Bunsen burner can cause glassware to crack or explode if not handled properly. To avoid these dangers, always use tongs or heat protective gloves when handling hot objects. Make sure your lab area is clean and free of clutter, especially flammable materials. Always turn off the gas completely when you're finished using the burner. Never leave a lit Bunsen burner unattended. Always use appropriate heat-resistant glassware. Always tie back long hair and avoid loose clothing. Remember, if you're unsure about anything, don't hesitate to ask for help or clarification. That's what I'm here for.
That was a very in-depth response. So, continuing on with our procedure.
The halogen present in the compound reacts with copper to form a volatile copper halide which imparts blue or green color to the flame. Strontium gives crimson red color in the flame test. It is due to the excitation of electrons by the thermal energy, which is then followed by the excitation of electrons to ground state along with liberation of light in the visible range. Potassium is colorless or in white, but when it is heated, it produces violet flame due to excitation of the electrons to the higher energy orbitals. Potassium burns with light purple colored flame.
Okay, we have our quiz. And there we go. Now we can continue our simulation, continuing to talk with Dr. Arnold here if we'd like. For example, hey Dr. Arnold, can you tell me, or can you relate to me, if the reason that the copper burns green is at all related to why when it's left out, it, like a penny, will turn green? Can you answer in under 3 sentences?
Absolutely. The green flame in the flame test is due to the reaction of copper in the compound with the flame, producing green-colored copper ions. However, the green color you see on aged copper items, like pennies, is due to a different reaction. It's the result of copper reacting with oxygen and carbon dioxide in the air over time, producing a layer of copper carbonate, which is green.
All right. So with that, we've easily added AI to our simulation, which we're able to question and query based off our topics in here. Let's exit this simulation now. So now that we are back here, we can make additional changes to here if we would like. Other optimizations that I know that we could do here, looking at our scenario flow, is we could make it so that you're able to clean your substance here, so you don't necessarily have to burn it at this point. To do that, I would make it so that I would copy this here, so that if they wanted to, for each of these, you could transition back to here. That way, if they've gathered the sample, it will let them clean it there if you wanted to. Alternatively, we could use rules and conditions for turning on the Bunsen burner so that the user is able to turn it off and on whenever they would like. However, I feel like probably the best thing that we could do here is change all of these display messages to speak actions for Dr. Arnold. So in order to do that, I would just very simply go here for my speak action, create it, and adjust the position here where it matches my display message. Select Dr. Arnold and give him the Justin voice and delete this display message here. And I'd be able to go through here and optimize this for each of these for going through here to make adjustments to my simulation. We can also go through here and make specific feedbacks for which one that they got incorrect. So if they got it correct, they know it, and we showcased a green and purple one. And if they selected either of those, we could give them a message saying, no, don't you remember that the selected value of, let's see, which one was green or purple? D and E. D. And so if they select D, that goes here. Selected green. I probably should have done this. And changing the destination to this. Selected green. And in this case, I would make it so rather than, I'm sorry, that's incorrect. As a reminder, strontium was one of the samples that we burned, and it burned red when introduced to the flame. The color that burned green was copper. And we would just need to change this to where correct is equal to true here, and or correct is equal to false, and selected does not equal D or E. Okay, because this way, if not equal to A, B, C, D, E. Okay, because otherwise, if they selected E or D, we still know it's going to be incorrect, but we do not want it to go here if it's just not correct, because if it's one of these, we want it to go to this special one instead. And we can copy this. Selected purple. The color that burned purple was potassium. I think I spelled that right. And add a transition here of a condition based off the question, where the selected is E. Okay. So with that, we have our setup here done properly based off of this. And you can make other adjustments and changes to this as you see needed or see fit to match your desires for the simulation. I hope that this was helpful for you. Have a good rest of your day. Thank you.